Hello everyone and thank you for joining my course. In this lesson, we will calculate the properties of the fluid viscous dampers, and we will first start with
Damper frame design. The selection of the damping constant follows a perspective approach, which is first, a linear damping constant is calculated based upon achieving the requirement viscous damping ratio, the fundamental period and the stiffness of the floor where the damper will be located. Then a pseudo velocity is calculated based upon the fundamental translation period and used to translate the linear damping constant to a nonlinear damping constant with a damping exponent of 0.4. In order to calculate the linear damping constant, the required viscous damping ratio must be determined. According to the FEMA linearization approach, the calculated target displacement is 88 mm. Considering that the reinforcement is assumed to yield at a strain of 0.002, yielding of the first floor column's reinforcement is anticipated at a roof displacement of 39.3 mm in X direction. In summary, as long as the roof displacement is limited to the values, the structure is expected to remain within the elastic region. The primary objective of the damper system is to reduce the displacement demand from 88 mm to 39.3 mm, thereby ensuring that the structure remains within the elastic range. Based on this, the corresponding viscous damping ratio is determined as follows. Whereas QER is 39.3, QE is 88 mm. The value of the linear damping constant C can be obtained using the following equation. Whereas K is the story stiffness obtained from the static analysis of the building, obtained from equivalent lateral force method, and the number of dampers in each direction under investigation. For the design example, the following information is provided. Since 2 dampers will be installed in each direction on every story, the value of N is equal to 2. To equate a linear damper with a nonlinear damper, the following equation will be used. A velocity exponent of 0.4 is adopted to reduce the damper force while still preserving the same level of energy dissipation. For calculating the value of D, the damper displacement, a model response spectrum analysis must be performed. The displacements obtained from the response spectrum analysis are shown in the figure. These displacements have been scaled by CD over R. Then the damper displacements associated with the story drift is calculated and used to determine a pseudo velocity. The table below shows the drifts, the displacements, velocities, and the non-linear damping constant of the dampers. The ratio of the determined nonlinear damper constant to the target nonlinear damping constant must be greater than 0.9 and less than 1.3. The final nonlinear damping constants value, which are suggested for Taylor devices dampers, are given in the table. Once the final nonlinear damping constant value is obtained, the velocity is modified to reflect the influence of higher modes as well as nonlinear response. For the determination of the damper forces, the velocities must be modified. The adjusted velocities are summarized in the following table. The amplified velocity is used to determine the corresponding damper forces at the DE, MCE, and overstrength levels. The calculated forces are shown below. The nominal damper force is defined based on the demands at the MCE level. Accordingly, dampers are selected with nominal forces of 500 kN for the fourth and third floors, 750 for the second floors, and 1000 kN for the first floors. To determine the required stroke, the displacements obtained from the model response spectrum analysis must be amplified using the omega factor developed for stroke estimation. In addition, the damper must satisfy at least the minimum threshold of 3% inter-story drift. Dialer generally provides stroke capacity in increments of 25 mm. Therefore, for this example, the manufactured dampers will be provided with a stroke capacity of 100 mm. The following table summarizes the damper properties that will be considered complete for the specification of the damper order.
Thank you everyone. In the next lesson, we will assess the performance of the structure equipped with the viscous dampers.